Volcanoes have been erupting on our planet for billions of years, shaping continents, creating islands, and occasionally wiping out entire communities in sudden catastrophic events. Yet despite enormous advances in volcanic monitoring technology, despite decades of scientific research, despite historical records that clearly show which regions are most dangerous, people continue to die in volcanic eruptions with alarming regularity. The question that haunts us is not simply why volcanoes are dangerous, but why we seem unable to prevent the disasters they cause. Why, in an age of satellite communications and sophisticated computer models, do volcanic tragedies continue to happen again and again? The answer lies not in the power of the volcanoes themselves, but in a complex web of human decisions, economic pressures, political failures, and the fundamental limits of what science can predict. To understand why volcano disasters keep happening, we must first understand what volcanoes actually are and how they pose a threat to human populations. Our planet's crust is divided into massive tectonic plates that float on a semi-molten mantle beneath. Where these plates collide or separate, magma from deep underground can find its way to the surface, creating volcanic eruptions. The violence of these eruptions depends on the chemistry of the magma, the gas it contains, and the pressure built-up before the eruption begins. Some volcanoes erupt gently, with lava flows that allow people to evacuate slowly. Others explode with tremendous force, sending superheated gas clouds racing down slopes at speeds exceeding hundreds of kilometers per hour, burying everything in their path under meters of ash and rock. The types of volcanic hazards that threaten communities are remarkably diverse, and this diversity itself creates challenges for disaster preparedness. Pyroclastic flows, those deadly clouds of gas and volcanic matter, are perhaps the most feared phenomenon because they are essentially unstoppable. Once they begin, and they kill everything in their path. Lahars, which are volcanic mudflows created when ash mixes with water from melted snow or heavy rain, can bury entire river valleys hours after an eruption has ended. Ashfall from volcanic eruptions can collapse buildings, destroy crops, contaminate water supplies, and create respiratory problems that persist long after the eruption itself has finished. Lava flows, while slower than pyroclastic flows, still destroy everything in their path and cannot be stopped by human intervention. Each of these hazards requires different preparation, different evacuation plans, and different responses from communities. Now here is where the story becomes complicated, because the scientific understanding of these hazards has grown tremendously over the past century, yet this knowledge does not automatically translate into saved lives. The fundamental reason volcano disasters keep happening is that human beings continue to settle in dangerous places, often because those places offer economic opportunities, agricultural fertility, or cultural significance that outweigh the perceived risk. The slopes of volcanoes are incredibly fertile due to the volcanic ash that decomposes into nutrient-rich soil. Valleys downstream from volcanoes provide water for irrigation. Coastal volcanoes often create natural harbors. These benefits have drawn human settlements to volcanic regions for thousands of years, and they continue to do so today despite the known dangers. The population pressures facing our world make this pattern particularly troubling. As global population continues to grow, more people are forced to settle in areas that were previously considered too hazardous or too marginal for agriculture and habitation. In countries like Indonesia, the Philippines, and Central American nations, volcanic slopes support dense farming communities precisely because the soil is so productive. When these volcanoes erupt, the death toll can be catastrophic precisely because so many people live in the danger zones. The economic logic that drove these settlements in the first place makes it incredibly difficult to persuade people to leave, even when scientists warn of impending danger. The farms provide livelihoods, the community provides social support, and the perceived risk often seems abstract compared to the immediate needs of survival. The history of volcanic disasters is unfortunately full of examples where warnings were issued but not heeded, often because the economic consequences of evacuation seemed worse than the risk of staying. The 1991 eruption of Mount Pinatubo in the Philippines provides a fascinating case study in this dynamic. Scientists from the Philippine Institute of Volcanology and Seismology, working with colleagues from the United States Geological Survey, recognized the signs of an impending major eruption weeks in advance. They convinced local authorities to evacuate thousands of people from the most dangerous zones, and their efforts saved an estimated 20,000 lives. Yet even with this success, the evacuation process was chaotic and incomplete. Some residents refused to leave because they did not want to abandon their homes and livestock. Others left temporarily but returned when the expected eruption did not happen immediately, a pattern that would prove deadly in other eruptions. The psychology of risk perception plays a crucial role in why volcano disasters keep happening, and it is a factor that is often underestimated by scientists and policymakers. Human beings are remarkably bad at evaluating risks that are infrequent, but catastrophic, particularly when those risks are surrounded by uncertainty. A volcano might erupt once in 100 years, or once in 1,000 years, depending on its activity pattern. People who live near the volcano may have never experienced an eruption themselves, and their parents and grandparents may not have either. The memory of past disasters fades, and the sense of urgency diminishes. When scientists issue warnings, they must communicate uncertainty honestly, and this uncertainty can be exploited by those who want to minimize the perceived risk. The result is a dangerous gap between scientific knowledge and public action. The economic pressures that discourage evacuation and resettlement are immense and often underestimated by outsiders who wonder why people simply do not move away from dangerous areas. In many volcanic regions, the land itself represents the primary form of wealth for poor communities. Leaving means abandoning not just a home but a livelihood, a social network, and a place in the community. When governments order evacuations, they often lack the resources to provide adequate shelter, food, and income support for displaced populations. The economic disruption caused by evacuation can be devastating, and if the expected eruption does not occur or turns out to be less severe than anticipated, the political backlash against scientists and officials can be severe. This creates a perverse incentive for officials to delay evacuations until the danger is unmistakable, which is often too late. The infrastructure challenges of volcanic monitoring in many parts of the world compound these human factors significantly. The countries most affected by volcanic disasters are often developing nations with limited resources for scientific research and monitoring. Indonesia, which has more active volcanoes than any other country, struggles to maintain comprehensive monitoring networks across all of its potentially dangerous peaks. The Philippines, Japan, and Central American nations face similar challenges. When monitoring stations are sparse or poorly maintained, scientists have less data to work with, and their ability to predict eruptions accurately is diminished. The technology exists to monitor volcanoes effectively, but deploying that technology requires investment that many vulnerable nations simply cannot afford. The political dimension of volcanic risk management adds another layer of complexity to the problem. In many countries, local officials face pressure to downplay risks in order to avoid frightening tourists, disturbing real estate markets, or creating political instability. The economic interests of businesses that operate in volcanic regions often conflict with the recommendations of scientists who want to enforce stricter safety zones. When politicians become involved in the communication of volcanic risk, the scientific message can become distorted as it passes through multiple filters of political consideration. This dynamic has played out tragically in numerous eruptions around the world, where scientists knew about the danger but were not given the authority or the platform to communicate that danger effectively to the public. The communication challenges of volcanic monitoring deserve special attention because they reveal a fundamental mismatch between how science works and how people make decisions. Scientific predictions about volcanic eruptions are necessarily probabilistic and uncertain. Scientists can say that the probability of an eruption has increased significantly, but they cannot say with certainty exactly when the eruption will occur or how violent it will be. This uncertainty is scientifically honest, but it creates challenges for public officials who must decide whether to order evacuations. An evacuation that proves unnecessary can cost millions of dollars and destroy political careers, while an evacuation that comes too late can kill thousands. The asymmetry between these outcomes makes it psychologically easier to err on the side of inaction, even when the scientific evidence suggests that action is warranted. The case of Mount Vesuvius and the destruction of Pompeii in 79 AD represents one of the earliest documented examples of a volcanic disaster that occurred despite available knowledge. The Roman writer Pliny the Younger left detailed accounts of the eruption, and archaeological evidence shows that some residents had recognized the warning signs in the days before the eruption. Yet the city was not evacuated, and when the catastrophic pyroclastic surge arrived, thousands of people were trapped. The lesson from Pompeii is not that ancient people were ignorant of volcanic danger, but that recognizing danger and taking effective action are two very different things. This lesson has been repeated countless times in the centuries since. The 1902 eruption of Mount Pellicopirite on the Caribbean island of Martinique provides another tragic example that illustrates the same pattern. Despite previous eruptions that had demonstrated the danger, the city of Saint Pierre was not evacuated when the volcano began showing increased activity. When the massive pyroclastic flow swept through the city on May 8th of that year, it killed approximately 30,000 people in a matter of minutes. The governor of Martinique had actually ordered an evacuation the day before the eruption, but it was countermanded by French colonial authorities, who were concerned about the economic impact. The political interference with scientific warnings cost tens of thousands of lives in a disaster that could have been largely prevented. The 20th and 21st centuries have seen numerous additional examples that demonstrate the persistence of this pattern. The 1985 eruption of Nevado del Ruiz in Colombia generated lahars that buried the town of Armero, killing approximately 23,000 people. Scientists had warned Colombian authorities about the danger, and the Volcanological Observatory had issued timely warnings. Yet the communication chain failed at multiple points, and residents of Armero received little or no warning before the deadly mudflow arrived. The disaster prompted major reforms in Colombia's volcanic monitoring and civil defense systems, but it also demonstrated how many failures must align for a catastrophe to occur and how easily the system can break down. The 2010 eruption of Mount Merapi in Indonesia killed more than 300 people, despite years of scientific monitoring and repeated warnings from Indonesian volcanologists. The disaster occurred because many residents refused to evacuate from the danger zones, either because they did not believe the warnings or because they were reluctant to leave their homes and livestock. Some who did evacuate returned to their farms when the immediate danger seemed to pass, only to be caught when the eruption intensified unexpectedly. The patterns observed in Indonesia have been repeated in the Philippines, Japan, and elsewhere, demonstrating that the challenges of volcanic disaster prevention are remarkably consistent across different cultures and political systems. The role of media in shaping public perception of volcanic risk is another factor that cannot be ignored when asking why disasters keep happening. The media tends to focus on spectacular eruptions and dramatic rescue efforts, rather than on the slow and glamorous work of volcanic monitoring and preparedness. This creates a cycle where public attention spikes during major eruptions and then fades quickly, making it difficult to maintain political will and funding for prevention efforts between disasters. The media also sometimes sensationalizes volcanic events in ways that can undermine public trust in scientific authorities, presenting conflicting opinions from non-experts as equivalent to the assessments of professional volcanologists. The relationship between scientific institutions and the media is itself problematic because scientists are trained to communicate uncertainty while journalists often prefer simple, definitive messages. When a volcanologist explains that the probability of an eruption has increased but remains uncertain, this nuanced message can be difficult to convey in a headline or a brief news segment. The result is sometimes a distortion of scientific findings, with uncertainty being stripped away and replaced by alarmist predictions or, conversely, with danger being minimized. This communication challenge is not unique to volcanology, but it is particularly consequential given the life or death stakes involved. Now let us consider the scientific limitations that contribute to the persistence of volcanic disasters. Despite remarkable advances in our understanding of volcanic processes, prediction remains an inexact science. Volcanologists can identify volcanoes that are likely to erupt in the near future, and they can often detect the precursory signals that precede an eruption, but they cannot usually predict the exact timing or magnitude with precision. This uncertainty is not a failure of science, but rather a reflection of the inherent complexity of volcanic systems. Magma chambers are hidden deep underground, and the processes that trigger eruptions involve interactions between fluids, gases, and rocks that are difficult to model accurately. The specific sequence of events during an eruption can also be difficult to anticipate. A volcano that scientists expect to produce relatively gentle lava flows might instead produce an explosive eruption that generates pyroclastic flows. A volcano that appears to be quieting down might suddenly reawaken with catastrophic force. These uncertainties create challenges for emergency planners who must decide how far to extend evacuation zones and how long to maintain evacuations. The cost of over-preparing is economic and social disruption, while the cost of under-preparing can be measured in human lives. The global distribution of volcanic risk creates additional challenges because the expertise needed to monitor and respond to volcanic emergencies is not evenly distributed around the world. When a major eruption occurs in a country with limited resources, international assistance can be crucial. But coordinating that assistance takes time and coordination that may not be available in the chaos of an unfolding disaster. The scientific community has made efforts to improve international cooperation in volcanic monitoring and response, but these efforts remain incomplete. Many potentially dangerous volcanoes in developing countries still lack adequate monitoring, leaving scientists unable to provide the early warnings that could save lives. Education and community engagement represent potentially powerful tools for reducing volcanic disaster risk, but they are also areas where progress has been slow and uneven. In an ideal world, communities living near active volcanoes would understand the hazards they face, would trust the scientists who monitor those hazards, and would participate actively in planning for emergencies. In practice, this level of engagement is rare. Many volcanic communities are poor, with limited access to education and information. The cultural context of risk perception varies enormously, and what makes sense from a scientific perspective may not align with local beliefs and practices. Building effective communication between scientists and communities requires time, resources, and cultural sensitivity that are often in short supply. The case of Iceland provides an interesting example of how investment in monitoring and preparedness can reduce volcanic risk. Iceland experiences frequent eruptions due to its position on the mid-Atlantic ridge, and the country has developed one of the world's most sophisticated volcanic monitoring systems. When the 2010 eruption of Eyjafjallajökull disrupted European air travel, the advanced warning provided by Icelandic scientists allowed authorities to implement safety measures that almost certainly prevented casualties. The economic disruption was significant, but the human toll was remarkably low given the magnitude of the eruption. Iceland's experience demonstrates that volcanic disasters are not inevitable, and that investment in science and preparedness can save lives. Yet even in well-monitored regions with advanced scientific capabilities, the human factor remains the weakest link in the chain of disaster prevention. The 2018 eruption of Kilauea in Hawaii, while not causing any direct fatalities, revealed the challenges of managing volcanic risk in communities that are deeply attached to their land. Despite mandatory evacuation orders, some residents refused to leave, and others returned to their homes before it was safe to do so. The eruption destroyed hundreds of homes and created new hazards with toxic gases that caught some people by surprise. Experience of Kilauea demonstrates that even the best scientific monitoring cannot prevent disasters if communities are not willing or able to follow the guidance that scientists provide. Looking at the broader pattern of volcanic disasters over the past century, we can identify several common factors that contribute to the persistence of these tragedies. First, human populations continue to grow in volcanic hazard zones, drawn by the economic opportunities that these regions provide. Second, the communication of scientific uncertainty to the public and to policymakers remains ineffective, leading to both overreaction and underreaction to volcanic threats. Third, political and economic pressures often discourage the proactive measures that would be needed to prevent disasters. Fourth, the resources needed for comprehensive volcanic monitoring are not available in many of the countries most at risk. Fifth, education and community engagement efforts have not been able to overcome the human tendencies that lead to risky behavior. The question of why volcano disasters keep happening is ultimately a question about the relationship between scientific knowledge and human behavior. We know more about volcanoes than ever before, but knowing is not the same as acting on that knowledge. The gap between what science tells us and what we actually do represents the central challenge of volcanic disaster prevention. Closing that gap will require not only better science but better communication, better governance, better education, and better economic policies that reduce the pressure that drives people into dangerous areas. The good news is that we are not starting from zero. The international volcanic science community has developed best practices for monitoring, communication, and emergency response. Countries like Japan, Iceland, and the Philippines have demonstrated that it is possible to reduce volcanic casualties significantly through sustained investment in science and preparedness. The challenge now is to extend these successes to the many regions that remain vulnerable and to maintain the political will and funding needed to sustain these efforts over the long term. The disasters of the past do not have to be repeated in the future, but avoiding them will require learning from those disasters and committing to the difficult work of prevention. In the end, the question of why volcano disasters keep happening is really a question about what kind of future we want to create. Do we want to continue to repeat the mistakes of the past, building in dangerous places and failing to prepare for risks that we know are real, or do we want to apply the knowledge that we have gained to build a world where volcanic eruptions, while still dangerous, no longer claim thousands of lives with each major event? The answer depends not on the volcanoes themselves, which will continue to erupt as they always have, but on the choices that we make as societies and as individuals. The power to prevent volcanic disasters lies within our grasp. The only question is